Welcome to the webinar on HVAC humidity control with Altaire Systems, an Academy Energy Group technology. Presenting today will be Bill Steiner, the Director of Engineering for Altaire Systems. Bill has extensive custom air handling design experience and will present the technical portion of today's presentation. Greg Harrington is the Vice President of Altaire Systems. Greg has extensive manufacturing experience, including both aerospace and nuclear. Greg brings great manufacturing knowledge along with the project management rigor as a PMP from the Project Management Institute. He will present some of our projects and case studies today. Today's objectives are to review the following. Why do we need to dehumidify? Methods of dehumidification. What is decoupling? How is decoupling more efficient? How do we decouple? Why do we need to reheat? How can this methodology be deployed? What are real-world examples?
Aloha, everyone. Welcome. It's great to be here. We've been looking forward to having this session kind of in a later Eastern time zone. Greg and Bill are both in the Eastern time zone. Want to have this in the time zone that was a little bit more comfortable for our good friends in Hawaii to join in and participate. And we're really excited that you're here. I know there's people from around the country. If you want to drop in the chat, say hello and where you're from, that'd be great. So we'll get going here. Okay, so Greg, can you go to the next slide? Today we're going to talk about HVAC and chilled water. We are very committed to Hawaii and very committed to the Pacific. Our solution for dehumidification is really a great and perfect solution for those climates. We had the honor last year of going to Honolulu and participating in the Society of American Military Engineers. Looks like Eric is here. How you doing, Eric? Good to see you. So we participated in the 2025 SAMI Indo-Pacific event. We plan to continue to participate in that, and we want to get to know you. We want to establish these relationships and really work together to solve what are some challenging issues out there. Next slide, please. We have award-winning technology. The GSA Green Proving Ground and the U.S. Department of Energy, the High Impact Technology Program, have recognized our solution as a best solution. And we have some data that there's going to be some industry reports coming out soon. And we'll tell you a little bit more about some of those. Greg's going to tell you about some of those results from the Navy project. Next slide. When we were out in Hawaii, we had the great opportunity. I think some of you on the call here know Dan Mestis from Hawaii Energy. We did a briefing with them, and our technology has been approved for custom utility rebates. Now, that's both for new construction and for retrofit and renovation. One of the things that we can do, and if you can go to the next slide, Greg. One of the things that we can do for you as a part of either a retrofit or a new construction is, and really it's kind of a part of the process with the custom utility rebates, is to do some of the modeling. So we're going to go a little bit more into that, but NREL had predicted a 30% energy savings with our HVAC load savings with our technology, and you'll see some data later from Greg on the Navy examples where we exceeded what was even predicted, and they used the Energy Plus for that modeling. We do also have some other energy modeling tools for both new construction or retrofit renovation that we can share with you. Next slide, please. So today we're going to have really two parts to this. We're going to go through the technology. Bill Steiner is our Director of Engineering. He's going to go through the technical piece of this conversation. And then Greg Harrington is going to go through some of the project examples and some case studies and some relevant, performance data of how the system is performing based upon feedback from Department of Energy, Navy, GSA, and even VA. So from there, let's hand it off to Bill Steiner. And aloha from Peter Keating. Hello, Peter. Thanks for being here. Bill, go ahead.
Thanks, Andy. So our objectives for today, I want to talk about why we need to dehumidify, what our two primary methods of dehumidification are, what is decoupling, and why is decoupling efficient, what is a desaturation coil and how does that work, why we need to reheat, and how we can deploy this technology. So what is ADAPT? ADAPT is Advanced Dehumidification Airstream Pretreatment Technology. Why do we need to dehumidify? Generally, ASHRAE is going to require us to bring in 20% outside air. The reason I say generally is if you actually look at the standard here, there's about 3.5 pages worth of table that tell you based on your occupancy, space use, all those sorts of things, how much outside air you actually need to bring in. As a rule of thumb, would say 20%. Also in ASHRAE 62.1, we set a maximum dew point of 60 degrees allowable in the space. Generally, unless we have a more stringent space condition, we're going to design to about a 55-degree leaving dew point to allow for gains, latent gains in the space, and to give us some buffer. No one ever likes to be right up against the requirement. So what does that mean? And I apologize. There's a lot of folks from Hawaii. This is the continental United States on here. But this map is to drive some of my audience members who are not as familiar with humidity as you folks might be. That, hey, even in Ohio where I live, up in Minnesota, even in the summer, you've got to think about humidity. The dew point gets high. It's a concern you need to address it, because if you don't address that, you're going to end up with situations like this where you have mold, mildew, condensation inside the building, nothing that anybody wants inside their space. So what are the two primary ways that we can dehumidify? There is desiccant, which is the means by absorbing the moisture out of the air, or there is subcooling, which is the means of making the air so cold the moisture can't be in that airstream anymore. It literally wrings the moisture out of the air. The focus of our discussion today is going to be on the subcooling route. We will touch on desiccant just a little bit, but the highlight here is subcooling. Whether you're doing it with DX, water, it's a coil. It's a lot more simpler method than desiccant, where you have a media, a regeneration cycle, two different airstreams in the case of a wheel, really two different airstreams in the case of liquid as well. So when we talk about subcooling with water, how low can we go? This chart here I put together, there's some assumptions on the left that assume some design characteristics, but in generalities, this will get you in the neighborhood on just about any application based on your chilled water temperature, about what dew point you could expect to achieve. So with 48-degree water, we can hit a 50-degree dew point pretty comfortably. 50-degree water, you can get down to 52.5. So for most general use space requirements, we can get there with 50-degree water. When you look at your total chilled water system, the energy savings at the plant, being able to lower that, or I'm sorry, raise that chilled water temperature, has a pretty significant impact on total energy savings. So what is decoupling? Simply decoupling is taking the outside air and treating that separately before we mix that with the return air. The main reason for that is, as we discussed previously, the bulk of our latent gain, our humidity concern, if you will, within the space is from the outside air that we bring in. So what that means, especially in a system where we need to subcool, or even if we're using desiccant, if we're doing that dehumidification before we mix it with return air, and remember, our outside air represents roughly 20%, depending upon the scenario, of the total airstream. It's way more efficient to do that work to just 20% of the airstream than it is to mix it with the return air and have to do it to 100% of the supply air volume, right? And there are some examples with math that will illustrate that in the next slides. Some of the other advantages of this method as well. You can use supplier temperature resets. It's a chilled water coil. As long as you've got that valve open and you're flowing water to it, it's going to work. It's going to subcool. It's going to provide your dehumidification. And it's not something cantankerous like a wheel where if you set it back too far or if conditions give a little too out of a line, you're going to lose control of the system and you're not going to be able to get them back until the ambient temperature changes to a point where you can come back into control. Additionally, low cost of ownership. It in terms of dehumidification equipment, what this is, it's a chilled water coil. It's coated. It doesn't get any simpler. It allows for really low life cycle cost, total cost of ownership, and we will explore that in a little bit as well. So what does this look like from a savings side? This is an example of a peak day, and the important thing to note here is a peak load day is 1% of the time, or 0.4%, depending upon what criteria we're using to design to. This is our exception to the rule. The part load days pretty much the rule, right? That's the other 99% of the time. So on a peak load day, we're not going to expect too much energy savings, right? We just want to meet conditions, meet demand, um, and be able to serve the building. So we look at the top scenario here. This is without pre-treatment. We have outside air, 92 degrees dry bulb, 72-degree dew point. We're bringing that in with our return air. We're mixing that. That gives us 72-degree dry bulb with a 58-degree dew point. We have to subcool that air. We have to get that down below 55 degrees dew point to meet our set temperature. So we cool that. We'll pick up a little bit of heat of fan, leave the unit 56 degrees dry bulb, 54-degree dew point. So we've done all our work. We've used 146 gallons of chilled water to do that work. Conversely, same, excuse me, same outside air conditions, same return air conditions, and now we are pre-treating that outside air, and just that outside air, we're gonna bring that down to a 54-degree dry bulb with a 48-degree dew point. When we mix that, that's going to give us a 70-degree dry bulb, the 52-degree dew point. Great. Now I don't have to subcool anymore. I've just got to apply whatever sensible load I need to cool to on that chilled water coil. And in this case, I'm going to be able to do that with 49 gallons per minute of water. I'll pick up again a little bit of heat of fan, and now I'm supplying air that meets the set points. The difference in these two scenarios here, without pre-treatment, we used 146 gallons per minute. With pretreatment, we use 76 gallons per minute. Everything else was the same. The same delta T's on the coils. At least the AHU coil was used. Um, the adapt coil has a little bit higher delta T, but other than that, it's all the same parameters. The difference here is I did all of my dehumidification on just the outside air. So that's the difference there. Again, part load day. And this is where we really see the savings, right? So again, same setup. The top is without pre-treatment. This time at 77-degree uh, air with a 66-degree dew point. We mix that. We end up with 74.5 degrees with a dew point of 57 degrees. We still have to subcool all that air now. So now we've got to cool that all the way down 54 degrees to be able to hit our required dew point. But because we did that, now we're subcooled, right? This is a part load day. We don't need 55-degree supply air. Now we're too cold. Now we've got to apply some reheat to this somewhere in the system. Otherwise, the space is going to be a little cold and clammy. It also took us 125 gallons per minute of chilled water to do that. Again, same scenario below, except we're pre-treating. Same leaving conditions coming out of the adapt unit. Mixed air conditions are 70 degrees, 52-degree dew point. Now all we've got to do is put about 10 degrees of sensible cooling into this airstream and we're golden, right? So that's what we do. Takes us 19 gallons at the AHU, and we pick up our 2 degrees heat of fan, and we're supplying exactly the required air for this condition. And in this case, it was 42 gallons per minute of water when we decoupled versus 125. So this is pretty impactful on chilled water savings just by decoupling. The other important part of this is the reheat. How do we do that? We use a desaturation coil. How a desaturation coil works, for those of you that are familiar, I'm sure everyone on this call is, it's best to think of it as a chilled water coil and a hot water coil that we mated together and connected. You can see on the slide here, or this picture here on the slide, where we've tied the leaving side of the chilled water coil, this being the chilled water coil, over to the entering side of a hot water coil. And what we're doing is using water side recovery to take the heat that we reject into the water stream to subcool that air, to put about 4 degrees of sensible reheat into that, back into that airstream, to bring it up off the saturation line. Well, why do we want to do that? Well, we don't want to send fully saturated air anywhere that we don't have to. I'm sure all of us in our careers have seen a unit or filters that look like this. There's standing water inside the unit. The filters start to grow mold. All of that happens because there's moisture in the airstream. And the easier it is for that moisture to come out of the airstream, aka how close are we to that saturation line, the more likely these things are to happen. Also keep in mind, anytime you go across the coil, anytime you go across the filter, there's a pressure differential. Pressure differential also makes it easier for moisture to come out of the air, to have carryover, to have all the things that we don't want to happen inside of our unit. So that's why it's important that we reheat. That is a question that I will get from time to time. Well, why do we reheat? Why don't we just, I understand decoupling, but why don't we just subcool it and let it mix with the returner? Well, because then we're running a risk that if we don't apply that reheat, that we're not going to have these issues. And it's quite honestly not a chance worth taking. Excuse me. Speaking of energy, 90.1 is on a lot of people's minds. Energy standards. How does this help someone achieve compliance with 90.1? There's a couple ways. First of all, section for dehumidification. We actually meet 2 exceptions for this. Exception number 1 essentially refers to decoupling. So if 50% of your supplier volume or less is outside air and you treat that separately, you're allowed to use serious reheat and cooling. Also, exception 5, if at least 90% of your annual energy for the reheat portion comes from site recovered energy, you are allowed to use series reheat and cooling when it comes to dehumidification, because 100% of the energy, again, water side recovery is used in the adapt unit. This meets 90.1. Additionally, if you're in climate zone 0 through 4, you are not required to have exhaust side energy recovery if you have a series energy recovery ratio of 40% or greater. And that is a job by job calculation that we have to do, but we do qualify for that. We will design to be at least 40%. In many cases, it's a little bit more than that. So fully compliant with ASHRAE 90.1.
Hey,
Hey,
Bill, we
Bill,
got one.
oh, go ahead, Greg.
Yeah, we have one question come in on the chat, and it was, are you getting a 30 degree Fahrenheit delta T on the dehumidification coil?
Um, yes, Eric, it depends on several parameters. We are 30 is the upper end, 30 to 35. But that is just on the chilled water side. Um, Keep in mind that we're going to take some of that heat that we pick up during the dehumidification, and we're going to put that back into the air stream for our reheat. So our total delta T across is going to look more like 25 degrees. Does that answer your question? I see a thumbs up. Thank you. Okay, so how can we deploy this technology? In a nutshell, anywhere you have chilled water, I can find a way to make this work. So in this example here, we've got what would be a new air handler. You can see our mixed air section there in the front with our return fans, and below we have the adapt coil. So in this case, think of like a standard custom air handler you'd buy from any big name. Well, you can supply the same thing, but the difference is now you don't need a DOAS. You don't need separate equipment for the sake of decoupling. It's all included in one nice little packaged unit. Additionally, let's say you've got an air handler, it works well, and you don't want to replace it, but you also want to decouple, or maybe you don't have capacity. And there is a case study that speaks to this very scenario that Greg will discuss later. But okay, great. We've got a solution for that too. This little gray box here is the adapt unit. And all that we've got in there is the coil and some filters to protect that coil. And then the dark brown here is just your air handler that needs a little help. All you've got to do to install this, it couldn't be any simpler. You duct into your outside air intake on your AHU. It comes with pre-programmed controls. So you apply 120 volt power to it to run the controls cabinet, plug in your Ethernet to tie into your BAS, tie into your chilled water supply into the AHU, and this thing's up and running. And now that AHU that maybe wasn't performing, didn't meet 90.1, whatever the issue was with it. And again, Greg's going to give you a good example of this in real life. Now for pretty low effort, relatively low cost, you've made that unit efficient again. So some standard details, construction wise, that you should look for, especially when you're talking about a unit in a coastal area that's doing dehumidification. Excuse me. You want all non-corrosive construction, right? No brainer. But I still see specs and things out there where people will still call for galvanized. And that's great to save on that first cost, but even a powder coated, painted, galvanized unit, you're not going to get the life out of it that you're going to out of aluminum or stainless. Additionally, all of our coils are going to come, our adapt coils are going to come with the 10,000 hour salt spray rated coating. Um, it, that gets you your 40 years, right? So if you clean that coil, take care of your filters, it's coated so that it can stand up, especially again in coastal environments, to the salt laden air. You're going to get the life out of that. So that's something that um, you should consider as well, is that requirement to have those things coated, because for the upfront cost, you really do get the additional life out of it. Couple other things to consider: low face velocities, and there's several reasons for this. Um, Primarily, it's performance. We talk about, if you guys remember that big desaturation coil that I showed you, that's a deep coil. If I ran that at 500 feet per minute, there's going to be several problems, but first and foremost, it's going to need to be deeper because coil performance is affected by face velocity. But also, I'm going to have like 1.5 inches of pressure loss across that coil, and the whole point of this is to save energy. So I'm not really doing that if I'm running this thing fast. So what we try to do is keep our face velocities nice and slow, keep that static loss down. Additional things that that's going to help with is it's going to help reduce carryover, which is a concern when we're dehumidifying air by subcooling. Also, especially in a coastal environment, again, salt laden air. Air is abrasive. And the faster that we run air over that surface over a long period of time, the more it wears it down. So if we slow it down, it's actually going to help make our coil last a little bit longer. Additionally, everything that we build and send is going to come with pre-programmed controls for you guys. It is kind of an important part of making our system work, so that we take care of that. We don't expect another third-party controls contractor to be able to come in and figure our system out. That's part of the complete package that we're going to include.
And one quick
So,
note on that. Hey, Bill, hang on one second. One quick note on that. Our system is open protocol, so it will interface with the other BAS systems, and it's interfacing now with a few different manufacturers. So we have a ability to marry it up into the system. Go ahead, Bill.
so what are some common methods of humidity control and energy recovery? So dehumidification, energy recovery. Wheels, probably the most common thing. Uh, People use wheels. They are maintenance intensive. If you take the manufacturers at their word, um, that media lasts about 10 years. I think in practice, it's more like 5 or 8. So if you do a life cycle cost analysis and you do it by the book, and you're doing a government job where it's 40 years, you've replaced that wheel basically 3 times over the course of that. Whereas, our unit, that coil is good for 40 years. You're replacing your filters and cleaning it. Um, I've done some life cycle cost analysis for other customers where we compared a wheel to our technology, and when adjusted for inflation over 40 years, on a single unit, it was about $500,000 in savings, just in the difference between the maintenance and what these two require. So, last point to consider on wheels: yes, they'll give you about 40% savings when they're new, but that depends upon that percentage of savings being maintained depends upon, are my seals still good? Do I have leak by? Is my media good? Are my bearings good? Is this thing spinning equal and evenly as it's supposed to be? It's, again, wheels are very finicky. When they work, but when things start slipping on the maintenance front, they stop working as well as they did when they were installed. Again, versus a coil, chilled water valves open, the fins are still intact and they're clean. It's working. It's providing performance. Next method, runaround coils. Again, this is going to be energy recovery only. Runaround coils aren't going to be able to provide dehumidification. We're not going to have cold enough air in our exhaust stream that's going to be able to allow us to make that water cold enough to dehumidify. They are a good means of energy recovery. However, again, just know that if you're doing this, you're still going to have to subcool at some point. You're still going to have to provide a means of reheat if you're doing that subcooling to come up off your saturation line. So they do provide, in the case of cooling in the summertime, they do provide some pre-cooling, and there is some energy savings. It's just not the best solution. Honestly, runaround coils are best where you have a wintertime requirement and you can use them for preheating. Yes, Eric, to answer your question, they are HRHI. They're all essentially our base is going to be like a Tamco 1500 or like a Ruskin CD50, CD60. So they're all low leak, silicone lip seal, aerofoil blades. But if you've got if you've got another damper that you want, something specific that you need, we can supply whatever damper, whatever filters would be necessary. I've done jobs in the Capitol building where we were told you need to install this filter rack at the very last thing and don't ask any questions about what goes in there or what it is. Just install this to these dimensions. And you go, yes, sir. And that's what that is. So very familiar with some of those government requirements. So plate heat exchanger, essentially this is a runaround system without the running around. We're bringing the four air streams together instead of having the coils be separate. It's just one plate that is taking the heat from the outside air and rejecting it into the return air, or vice versa in the wintertime. We still have to subcool that air, and after we subcooled that air, we still have to reheat that air. And again, in this case, it only works if we've mixed our air first. So it works. It does provide some savings. It's not a means of dehumidification, but again, there are better ways. Wraparound heat pipe, again, same same song, different verse. It works. It allows you to do some savings on the energy side of things, but you still have to subcool. You're not decoupling by doing this. And now you've got 3 coils where I've shown you guys today that you can do the same work with just 2 coils by using water side energy recovery. So it works. It's just maybe not the best solution. Lastly, liquid desiccant systems. The long and short of these are they're complicated. They say that the media lasts about 5 to 10 years. I don't know that they've been around long enough for us to truly know how long that's going to last. I think I've seen these things at the show just the last couple years. I don't know how many of them actually exist out in the field, but when you just look at what their system map is, that's a lot of touch points. That's very complicated. I, as an engineer, like to design for simple. I believe in the KISS method, and to me, this kind of violates that. So, does it work? I suppose it does, but is there an easier, more simplistic way? There absolutely is.
Yeah, hey, there's a question in the poll, and we'd love to get more answers. If anyone who hasn't answered, if you can just take a look at that energy recovery question and maybe give us an answer. We'd love to hear your feedback. Thanks. Go ahead.
So, how does this technology save you guys energy? So we talked about decoupling. I think that we hit that point home pretty well. We talked about the integrated heat recovery. Again, that's that part of the desaturation coil where we're coming up off the saturation line. If you had a situation where you were supplying outside air directly into the space, you can do that with this. Even mixed air, you're not going to have to reheat that. So energy savings there. Excuse me. Again, the efficiency gains at the air handler, we've talked about those. When we make the air handler only have to do the sensible work instead of the latent and sensible work, um, that chilled water coil inside there works a lot smarter and a lot less harder. We talked about supplier temperature resets, and I can't imagine there's too many people on this call that care about a winter season option for energy recovery. Um, so don't take my word for it. We'll prove it to you. We have an 8760 tool where we'll take data from the nearest NOAA weather station. We'll use the normal averages for dew point and dry bulb temperature for every hour of the year, and we'll show you on that hour what your energy savings is over baseline. All I really need from you guys is what your supplier volume is, what your chilled water temperature is, and your utility rates. And we'll do the rest, and we can prove, okay, over um, you know, an annualized scenario, what can you expect in utility savings by using this technology? Um, Before I turn this over to Greg, does anyone have any questions for me? All right. Thank you, everyone.
All right. So as Andy alluded to at the beginning of the presentation, we've been fortunate enough to participate in a couple of government validated or government funded validation projects. So those projects stem out of the Department of Energy and the GSA. So relative to the GSA, before the current administration, they were actually structured, had a significant amount of money put into investing in alternate technologies. And the primary focus with GSA is the fact that they're the biggest portfolio building owner in the continental United States. So they've got a huge amount of interest on finding ways to make their buildings more energy efficient. So they've got dedicated resources through a joint program with the Department of Energy through their Building Technologies Office. So through the Green Proving Ground, that you actually apply for these validation projects, and you go through a series of reviews that are partnered with engineers from the Department of Energy. The national laboratories participate. And so you go through a down select process in finding technologies that the government wants to invest money and running through a validation program. So the two ones, again, the high impact technology catalyst through Department of Energy, and then the GSA Green Proving Ground. So the first project that we participated in was with the Navy down in Orlando, Florida. They were having a facility that was having tremendous humidity control problems. So especially when you got into those high humidity days near the peak load conditions, they found that they were actually losing control in the building. And it got to the point where condensation issues on the upper floors, rain from the diffusers was a consistent scenario. So what we've seen typical in humid climates where people are struggling to control humidity, the building operators make decisions that end up being detrimental and actually making the situation worse. So in the case at Orlando, what they were doing, because they couldn't control the outside air, they were actually closing their outside air dampers. And so not only were we having a humidity control problem, but it in essence, they were creating a ventilation problem as well. And so part of it was the fact that the original design was under ventilating based on 62.1 requirements based on occupancy and the loads that were seen in the spaces that Bill was talking about earlier in the webinar. And so part of the validation project that we do, we actually will go out onto site, and once we have all the design criteria, we'll actually check ourselves for actual performance. So when we went out and measured, at those outside air louvers, how much air was actually being introduced into the building, it was closer to 4,000 CFM. So really, between the humidity control problem and the lack of ventilation, this was an ideal fit, for our solution. And we had a very proactive energy manager on site who was looking at sustainment funding as an avenue to be able to bring this technology into his project. So they had a major project with updating their HVAC controls, part to try to improve part of that humidity control, as well as improving energy performance. So we coupled and combined with that effort extremely well. And that's really part of the advantage of the technology that we can provide, is the fact that it's very flexible with the application. So in this case, the idea of bringing more outside air in while saving energy without having to try to do the footprint of bringing in a dedicated outside air unit really gave the building owner flexibility in solving a problem in a cost-efficient manner. And so what did that actually look like? So remember, we were down at roughly 4,000 CFM. By the time it was said and done, we put our units in, we were able to bring in the outside air and bring that up to 34,000 CFM. And really, that's a significant increase over the design. And because we're doing the pre-treatment with our unit, and we looked at the configuration of the air handler, the static that was available at the air handler, we were actually able to size these units very economically, in the sense of only needing to provide coils and filters. And so the other advantage that we bring into this equation is, because we were dedicating a unit to each air handler, we were able to tailor the design performance to the zone that those air handlers were feeding. So it really allowed us to maximize the amount of efficiency, because we were controlling that outside air latent load to the requirements that those air handlers had relative to the zone set points. And so what did this actually look like? What we saw from a whole building perspective was a 16% reduction of the total annual electricity usage. So that was roughly 1 million kilowatt hours annually, and roughly 130K annually, just based on the current electricity rates. And so when Andy was talking about model data, he was referring to, an example of a whole building savings, roughly 16%. So it matches that pretty well. And the most probably important thing to keep in the back of your mind relative to this validation project is the timeline. So when we looked at base energy usage, we were looking at years FY21, FY22, when COVID was in full effect. So what we're actually reporting as an energy savings, that building was already in a reduced operating scenario for the comparison. So what does that all mean? That means we could actually potentially provide more of a savings because the baseline comparison for us on this project was when the building was at minimal manning, a lot of remote home. So the loads that building we're seeing for those timelines was reduced from normal operation and what they're seeing now. And the biggest thing that we really focus on is one of the intangibles and the non-measurables, which is, the noticeable difference on the indoor air quality. Not overly cool, but dry and comfortable. So that was one of the big changes that the tenants in the buildings have noticed from this Florida project. Does anybody have any questions relative to, what we set up here in Orlando? All right, I'll keep moving on. This gives you an idea. We had 7 outdoor air pretreatment units of various sizes. And again, based on the roof configuration, based on the zones that were being fed, the idea of being able to put a DOAS in and feed multiple air handlers, we provided a cost-efficient alternative. And really what we found, even with mounting these units on top of the penthouse, I know that some people have reservations to that. Our units went through Hurricane Milton when it blew through Orlando in October of 23, and we didn't have any damage or issues with performance. So to give you a little bit more details in Orlando, we have a snapshot of a BAS screen, and this is from an August morning. Again, the outside air temperature, 82 degrees Fahrenheit, 72 dew point. So again, in the kind of that part load condition near in the high end. Leaving our unit, it's cooled down to 64 degree dry bulb with the dew point just under 50 degrees. And what that allows is based on the loads coming back on the return air side, we're actually completing all of the dehumidification and cooling based on the return air loads that you need. So that mixed air, when it crosses the air handler coil, it needs no conditioning at that point. And that's one of the advantages of our unit. When we're doing that dehumidification, obviously we're bringing that dry bulb temperature down. So in certain scenarios, we're doing all the work on just a smaller portion of the airstream. Moving on to our next example, we had, again, a really unique humidity control challenge. This is in Western Massachusetts at VA Center. They have a sterile processing department that was having trouble during the peak humidity of the summer being able to maintain their relative humidity requirements for operating in the spaces. So they had a range of roughly 20% to 60%, and lost control on high humidity days. They were looking to kind of take the zone that they were feeding that conditioned air into and actually expanding more spaces. So this was a great opportunity for us to, again, solve a problem with a little bit different approach. And the troubleshooting and root cause analysis that went through was that their existing DOAS was not meeting the design intent, and that's why they made the decision to replace it. And so for us, we do have the dedicated outside air system option. For New England, this included not only the filters, but the preheat coil that you would need for freeze protection. In this case, it was hot water, fans and VFD section. And because we had a low end requirement on that relative humidity as well, we had humidifiers as part of this unit, because the wintertime in New England will get dry enough where you get really, really low relative humidity. And part of the other things that we include in the package are ionizers to try to eliminate biogrowth or reduce biogrowth on our coil, and then the adapt coil itself. So we have the ability to provide a dedicated air system with the bells and whistles. Again, Bill talked about the strength of our approach. We have standards on products that we like to use, but we also have flexibility if contracts or owners have particular needs they're looking for. Our final project was part of the GSA Green Proving Ground. This is in a courthouse in East Texas. So part of the challenges with dealing with old buildings is the existing footprint, how they've set up their air handlers through the years. This building was from the 1930s. So the basement had been reconfigured and was actually under a foot and a half of concrete because at one time it was a bomb shelter. So part of the challenge that we had here is we had a couple of air handlers down in the basement. We had an air handler up in the attic. And based on the volume of air that they needed, they only required one adapt unit to be able to provide conditioning for these three separate air handlers. So again, the building, same sign, couldn't control humidity on hot days, underventilated, great fit for us. What was unique about this is this was our pre-treatment unit, but because of the fact that we were moving air, up to the attic as well as to multiple air handlers, we put a fan inside of this unit. And this picture gives you an idea of the condition of the space with the bowed ceiling tiles. You see a picture of our unit. We were able to get it into the basement with that picture on the right by bringing it in sections. So we do design these to be modular so they can fit through doors. So this gives us a lot of flexibility on the retrofit side. One of the really important things that Academy does and does well is collaborate to deliver. So through our conversations with the Department of Defense, we found that the Resilient Energy Systems Design Guide that ASHRAE was putting together was under revision. We started having conversations with the folks at Searle who are putting this document together and talked about our approach. And it really outlines and follows a lot of the things this climate guide emphasizes, which is talking about the construction when you're near marine coastal environments. It's talking about the advantages of decoupling when it comes to air filtration. It really focuses on latent load control, what Bill was talking about really on the energy savings of decoupling. And then talking about the idea once the air is outside air is conditioned, the need to be able to be tempered before you mix it with return air. And these are all things that are listed in that Resilient Energy Systems Design Guide. And within that design guide, they identify the DOAS or an outdoor air pre-treatment unit, which is exactly a picture that you saw today with our presentation. So they've incorporated it, they've published it, they see the value of the approach that we have and have included it in their design guide. And always, we're one of the contributors. It's nice to get recognized, especially when the authors put their note in there, acknowledging the people that provided support. But it was, again, this speaks a lot to the core principles of who we are with partnering to win and collaborating to deliver, knowing that often one person doesn't have the the answer, but it takes a team effort to bring solutions together. And really, just closing out, the next steps, like Andy was saying at the beginning of the project, we are looking for you guys to come to us and start sharing your information on the challenges that you have. We have a standardized evaluation sheet that kind of hits points that are critical for us to be able to put together performance or costing, or like Bill was saying, for our energy model. We try to make it an easy tool to use. So that will be one of the things that come to you as part of the package Andy was talking about after the webinar. And that is pretty much it. You know, we're active on LinkedIn. Check out our websites. And that's it. Does anybody have any questions or comments, or feel like there was something we didn't cover?
Greg, there was a question that just came into the chat. Is clean, and this is from Michael Owens, is cleaning the 12 flush row adapt coil an issue? Can the coil be split for easier maintenance?
Bill, you want to answer that, or you want me to?
So, couple responses for you here. Typically, we find that with a pressure washer and a cleaning solvent, you can get that coil pretty clean. Yes, the way that it is made, you could, and it's funny, I was thinking about this today. You could, in theory, bolt the hot water section together and make your connection a union or a flange connection instead of a brazed or sweat connection, and you could separate those for the sake of cleaning. It's certainly something we would I could explore with you. To answer the lowest airflow, I am working on a project right now with some pretty low airflows. And I think the lowest one I have on this job right now is 496 CFM of outside air. So we can go a lot lower than 2500. Some of that confusion is at one point we thought we wanted to have standard sizes. We've kind of pivoted away from that a little bit. So whatever size requirement you have, we can handle it.
Yeah, we were written into a specification for 155 CFM air handlers. So we just need to know what your needs are, and we can adapt. The adapt can adapt.
Any other questions?
Greg, quick question from I hear Eric with Haas Brown. We've designed some systems in Hawaii, and we've done it. We've got that cold, clammy air problem coming out, and I think the people on here from Oahu could probably attest to this. There's not a lot of reheat getting installed in Hawaii. There's not a lot of VAV units with reheat on island. So if we were to put, can we get how easy is it to get a package system with an adapt unit, so I can get my dehumidification and then pick up that chilled, that reheat coil then on the other side of my air handler, so I can get to the comfortable supply air? Is that a package you guys would offer? And with your and with the onboard controls that manage everything to get the water flows correct?
Bill, I got to be honest, I'd feel more comfortable letting you handle that one.
By package unit, you don't mean a DX unit, correct? We mean just like a skid unit, a plug and play.
I mean a package. Could you? I mean, would you provide a package where it's like, here's your dehumidification coil, here's your reheat coil, here's your valves, here's your controller, pipe it in.
Absolutely. I'm working on a pretty big project now where the design criteria is single point power, single point piping connection. Um, it's in a place where labor is really hard to find and not very skilled. So the more that's done at the factory, the better. So absolutely, we could work up a standard design that you could just toss out to whatever facility needed it.
Yeah, and I don't think I did a good enough introduction to Bill. Bill Steiner is he's done custom air handler designing. So, while we have what we had is the original like some of the standard sizes. What we really need to do is understand what your projects are, what your needs are, what your challenges are, and then Bill will work with you to customize the solution to bring it to work for your particular project and needs. All right. Well, any other questions before we wrap up? Well, thanks everyone for joining today. We're going to work on getting a resource package out to everyone. Thank you so much for being here. Thank you. We'll look forward to our friends in Oahu and in Hawaii to hopefully see you guys in September. So we'll be reaching out to send you the resources and then look for where you have challenges and where you have needs, and we're here to help. And we'll see some of you or some of the people on the island in September. We're out there for the SAMI event this fall.